We've spent time looking at the deep mechanics of AI, how transformers process language, how multi-headed attention works, and how agents execute complex plans. But understanding the physics of an engine doesn't automatically mean you know how to build a winning race car. When we look at the data, a massive 95% of AI projects fail. They don't fail because the underlying math is flawed. They fail because the teams building them chose the wrong strategic architecture. If you take a massive reasoning model and assign it a simple task like summarizing chat logs, you are going to burn through your budget and severely throttle your application's speed. The tools are right, but the application is entirely misaligned. To avoid those fatal errors, we rely on a definitive 4-step framework. It acts as a strict decision tree blueprint designed to protect your return on investment and push prototypes out of your development environment and into the real world. Taking an AI project into production requires a shift in mindset. It stops being a math problem and becomes a rigorous exercise in business logic and risk management. Step 1 of this framework is defining the use case, and that process starts with a single, measurable business KPI. Think of a very specific metric, like a 15% increase in first call resolution. If you are unable to tie your project to a hard metric like that, you need to stop. All downstream engineering choices become meaningless without a defined target. Once the objective is clear, step 2 is model selection. This is where you face the central trade-off of AI development, balancing raw performance capabilities against the cost and latency of running the model. Your first major decision branch is choosing between a pre-trained API or a custom model. You navigate this by checking 3 specific requirements: your proprietary data, your privacy boundaries, and your need for infrastructure control. The playbook rule here is straightforward. If you want speed to market, use public APIs. If strict privacy and control are mandatory for your enterprise, host an open source model locally. But whatever you do, never invest the time and money to train your own model from scratch. You also have to remember what these models actually are. They are reasoning engines, not databases. If you need the AI to reference yesterday's sales figures, you use Retrieval Augmented Generation, or RAG, to pull those facts. You only use fine-tuning when you need to permanently alter how the model behaves or speaks. At the end of the day, model selection is simply the act of defining the boundaries of what your data is allowed to do, and who exactly is allowed to see it. The second major branch in the model selection step is deciding on the size of your engine. You have to weigh large language models against small language models. LLMs are the heavyweights. They have billions of parameters and operate as massive generalists. You deploy them when you need the AI to untangle messy logic, handle highly unpredictable user inputs, or engage in creative synthesis. SLMs, on the other hand, are highly specialized and cost-effective. They are your go-to engines when speed is your top priority, when you need to run AI on edge devices like a smartphone, or when you are processing millions of documents and need to keep costs low. The proven strategy for balancing these two is to start big, then optimize. You prototype your application using a massive LLM to validate the core idea. Once it works, you shrink your architecture down to an SLM and pair it with RAG to keep it smart and efficient for production. That brings us to step 3, adjust and adapt. This is where you layer prompt engineering, RAG, and fine-tuning directly onto the model. These 3 layers enforce your data structure, inject real-time facts, and dictate the precise behavior of your application. Finally, step 4 is deploy and monitor. Your model leaves the safe confines of the sandbox environment and locks into an orchestration layer, where it will start interacting with the real world. This combination, matching the exact size of the model to the task and applying highly targeted adaptation layers, is the only architectural path that delivers both enterprise-grade intelligence and actual profitability. There is a harsh reality to generative AI deployment. In traditional software, if a block of code works today, it works tomorrow. Generative AI is non-deterministic. Over time, your application will drift. As user behavior shifts and your underlying data changes, the model's performance, alignment, and accuracy will inevitably degrade. Because of this, our 4-step framework isn't a straight line. It operates as a continuous strategic loop, constantly evaluated by automated monitoring tools. When KPIs slip, your team must react. You cycle back to step 1, swap the model, and readapt the architecture. We've covered the complete journey, from the heavy math of transformer architecture to the precise deployment of autonomous agents. You now possess the full engineering stack required to stop chatting with AI and start building it.